All right, in this video, we're going to be talking about rationalizing fractions with binomial denominators. So what we have done so far is rationalize fractions with monomial denominators, meaning there's just one term in the denominator. Whether that term was real or whether that term was imaginary, there was just one term. So the idea of rationalizing hasn't changed. It's just how we're going to rationalize that changed. So just a quick review. To do either one of these, remember if you have a square root, you need two things to come out. So if it was a real one, we multiply by whatever was in the square root. In the numerator, we get 5 square root of 7. And in the denominator, you'll remember square root of 7 times square root of 7, square root of 7 squared is going to be just plain old 7. Okay, now, should we cancel the 7s here? No, we cannot cancel those 7s because this one is inside a square root and this one is outside the square root. Okay, so when it was imaginary, the process was very similar. The thing we need to get rid of is the I, because remember I is the square root of -1 and can't have a square root in the denominator. So in the numerator, 5 times I, 5I. And the denominator, 7I times I, that's 7I squared. Okay, now remember from the other video, I squared is -1. -1 times 7 is -7. So in both of those cases, we just multiply by whatever it is we're trying to get rid of, and that number times itself cancels out the square root because there needs to be two things to cancel out the square root. Okay, so when we look at binomial denominators, remember binomial means two terms. So here I have a binomial times a binomial. We need to practice with this before we are ready to do the rationalizing of the denominator. So binomial times binomial, I'm going to FOIL. Okay, so let's recall F on FOIL. F stands for first. Okay, so that's going to be this one times this one. Well, 3x times 3x is 9x squared. All right, and then O in FOIL. O stands for outer. So I'm going to take that 3x and I'm going to multiply this time times the -7. 3x times -7, -21x. Oop, my x didn't turn out very well there. Okay, so notice basically what we've done at this point is we've taken that 3x and we have distributed it to both things in the parentheses. So to finish out the FOIL, we're going to do the same thing with the 7. So I stands for enter. So I'm going to distribute the 7 right here. +7 times +3x, +21x. And then the last one, L for last. So I'm going to take that 7 and I'm going to distribute over here. +7 times -7, -49. Okay, now to write our final answer, we need to notice that these two in the middle are like terms, so we combine like terms, and look at these two. This one is negative, the first one there is negative, the second one is positive. So -21 and +21, those are opposites. They cancel one another out, and we're left with 9x squared minus 49. So when the numbers in the parentheses are the same except for their sign, that's always going to happen. These two in the middle are going to cancel out. And what we're going to be left with is only the a and the c, right? Because the b in the middle canceled out. Remember how it was ax squared plus bx plus c. Okay, let's take that same idea and let's look at a fraction. Okay, now don't write this part down because this is going to be wrong. Last time when we did this, when we had a square root of 7, we just multiplied by square root of 7 over square root of 7. So let's see what happens if we try that same technique. Well, 4 times square root of 7, 4 square root of 7, good so far. And then in the denominator, you can see I've got two things. I'm going to have to distribute that square root of 7 to both. So I'm going to have 5 square root of 7. And then the second one, the square root of 7 times the square root of 7, square root of 7 squared is 7. Okay, so remember the definition of rationalize is trying to get rid of the radical that's in the denominator. But look, I still have a radical in the denominator. Because of the distributive property, it didn't help me. It just moved the square root of 7 from being second to being first. But I still have a square root of 7. So we're going to need a different technique. When I have two numbers in the denominator, I'm going to use a FOIL idea. Okay, so write this down. This part is going to be correct. What we're going to multiply by is the same two numbers that are in the denominator, except that the sign in the middle is going to change. This one is a plus, so over here I need a minus. And if I multiply by that in the denominator, I have to multiply that in the numerator as well, because remember, I can't change the value, and anything divided by itself is 1. So this is just a cleverly disguised form of 1. Anything times 1 doesn't change its value, so this is okay. All right, let's see what we get when we multiply this one. Well, in the numerator, I'm going to need to distribute that 4 because I have two things, right? So I'm going to have to distribute 4 times 5 is 20. And then I'm going to distribute the 4 over here. 4 times the square root of 7 is just 4 square root of 7, right? Because remember, this one is outside the square root. This one is inside the square root, so you can't put them together. Okay, now let's see what happens in the denominator. All right, well, look at, I have 2 and I have 2. I have a binomial times a binomial. So anytime I have binomial times binomial, I'm going to FOIL, which remember is really just the distributive property twice. So first, I'll distribute the 5. 5 times 5 is 25. And now I'll distribute the 5 over here to the square root of 7. Positive 5, negative square root of 7, negative 5 square root of 7, right? Because the 5 is on the outside, the 7 is on the inside, so they can't multiply together and give 35. The 5 has to stay outside, and the 7 has to stay inside. Okay, now let's switch, and let's do the distributive on the square root of 7. So I'm going to distribute it here, and I'm going to distribute it here. So positive square root of 7, positive 5. Okay, now think about this for a second. Can I actually multiply those together and get 35? No, the 5 has to stay on the outside, and the 7 has to stay on the inside. All right, and then I'll distribute right here. Positive square root of 7 times negative square root of 7. Negative 7, right? Because square root of 7 times square root of 7, well, that is the square root of 7 squared, which is going to be 7. Remember, square root and square root are opposites, so they cancel one another out, and what I have left is just plain old 7. All right, let's get rid of that. Okay, so now we need to look and see if we have any like terms. So in the numerator, I see that I have a 20 and a 4 square root of 7. Well, those are not like terms. This one does not have a square root of 7. That one does. So I can't add them or subtract them. I'll just copy that down. All right, then in the denominator, I have this 25 with no square root on it, and I also have this 7 with no square root on it. Those are like terms. All right, 25 minus 7, that's 18. And then these in the middle both have square root of 7, but look what happens. Negative 5 square root of 7 and positive 5 square root of 7 cancel out. Those are opposites. And so at 0, I don't have to put anything else there. So that's why we need the opposite sign right here, because I need these two to be opposites so they'll cancel out. And then I always want to try to simplify this as much as possible. So I look at all the numbers on the outside. I don't consider the 7 because it's on the inside. I only look at the numbers on the outside. Is there anything that will divide into 20 and 4 and 8? Really, I'm looking for a GCF. What would be the GCF of 20 and 4 and 8? Well, the GCF would be 2. So 20 divided by 2 is 10. 4 divided by 2 is 2. Doesn't change the square root of 7. 18 divided by 2 is 9. And so that is going to work out to be our final answer. Okay, so a vocabulary word we need to be familiar with. This up here that we multiplied by, this is called the conjugate. Write that on your paper. That's a vocabulary word we need to be familiar with. The conjugate is the same numbers that I had before, but the sign in the middle is opposite. So we're always going to multiply by the conjugate right here. Okay, let's do another one. Okay, look at this one. So this one number on the top, monomial, 2 numbers on the bottom, binomial, but this time I need to try to simplify. Look at this one. 7 was a prime number, So there was nothing to simplify. But 24 is not prime. So let's see if we can do a factor tree on 24. All right, so I'm going to put 24 right here. Let's do a factor tree. I've got 6 and 4. 6 is 3 and 2. 4 is 2 and 2. And then remember how we talked about in class, we're just going to put an X on anything that's composite. We only want to focus on the prime numbers. Circle the pairs. Okay, now think about what needs to go inside the house and what needs to go outside. Okay, the -3 doesn't change. The -4 doesn't change. The only thing that's going to change is the 24. The circled thing, you guys remember, the circled thing comes on the outside. And the things that are not circled multiply back together on the inside. 3 times 2 is 6. Okay, so now we are ready to multiply. And remember, the thing we're going to multiply by is the conjugate. All right, I need a little more space here, so I'm going to get rid of this so I can multiply by the conjugate. All right, and the conjugate is the same two numbers, -4 and 2 square root of 6, but the sign in the middle is going to be opposite. So this one was a plus. I need this one to be a minus. And I have to do the same thing on the top and the bottom. Okay, so now let's distribute that -3 in the top. -3 times -4, positive 12. -3 times -2 square root of 6. Okay, so should we multiply the 3 by the 2, the 3 by the 6, or should we multiply both? Well, we should only multiply the 3 and the 2 because they're both on the outside. So I'm going to get positive 6. -3 times -2 is positive 6. Square root of 6 right there. All right, now let's FOIL in the denominator because I have a binomial and a binomial. I'm going to FOIL. So I'm going to distribute the -4 first. F for first, -4 times -4, that's positive 16. Now distribute the -4 over here. That's the O, that's the outer. -4 times -2 square root of 6. Okay, now think again. Which one do I multiply by, the -2 or the 6? I want to multiply by -2 because it's on the outside. So I've got plus 8 square root of 6. 6 is on the inside. I can't do anything with that one. All right, now let's do I. Let's distribute this one. 2 square root of 6 times -4, -8 square root of 6. Again, I'm multiplying the outside numbers, 2 and -4, and I'm just leaving that inside number there. And now let's multiply last times last. Okay, so this is going to be a little bit tricky. Positive times a negative, well, that's a negative. Now I multiply the outside numbers together, positive 2 and -2, that makes -4. I've already got the negative there. And now what happens with square root of 6 and square root of 6? Well, those are the same. Square root of 6 times square root of 6, that's the square root of 6 squared, which is just 6. Okay, so now let's see if we can combine like terms. In the numerator, we don't have any like terms. We'll just copy that down. And now in the denominator, well, 4 times 6 is 24. Let's make that a 24. 16 minus 24, those are like terms. 16 minus 24 is -8. And now how about these two? These are like terms. They both have a square root of 6. 8 square root of 6 and -8 square root of 6. Those are opposites of one another. They cancel out. And then I want to look at all three of these and see if I can simplify. All right, what's the GCF of 12, 6, and 8? Well, it's 2. 12 divided by 2 is 6. 6 divided by 2 is 3. Doesn't affect the square root of 6 because that's on the inside. And 8 divided by 2 is 4. Okay, remember how we talked about in the other video that they won't leave a negative right here? They'll always move it up to the top. So this final answer, if this was a standardized test, you would divide, 3 square root of 6, sorry, I put my square root too soon, and positive 4 in the denominator. They would not leave that negative in the denominator. They would change it and put it up in the numerator like that. So that works out to be your final answer.